Hello everybody, today I can perform isosceles triangle theorem mini-proofs using congruent sides or opposite congruent angles. I know an isosceles triangle has two congruent sides and the angles opposite them must be congruent as well. And vice versa, if I have a triangle that has two congruent angles, it must be isosceles, and the sides opposite them must be congruent. So we're going to apply that to proofs. Let's start with number 1. That would be a good number to start with. I'm proving, within the mini proof, I need to let you know which triangles are proving congruent. So I'm proving these blue triangles congruent. So angle ABC is congruent to angle ACB. So let's go statements, reasons. And let's just see if we can move this a little bit, make it not so giant. Oh my god. All right. So angle ABC is congruent to angle ACB, given. So are these angles of the triangles I'm trying to prove? The answer is no. So they gave it to me for a reason. My additional tools are VRIAS. V, vertical angles, nothing to do with vertical angles. R, reflexive property, nothing to do with reflexive property. I, isosceles triangle. Is there an isosceles triangle? Yes. If these two angles are congruent, it makes this whole triangle isosceles. And an isosceles triangle not only has two congruent angles, but the sides opposite them are congruent. And are the sides opposite them sides of the blue triangles? Sides of the triangles I'm trying to prove? Yes. So I can now state that segment AB is congruent to segment AC, and the reason, isosceles triangle theorem. And what isosceles triangle theorem states, if your teacher is not going to accept this, in a triangle, congruent angles are opposite congruent sides. So if they give you something that's not in the triangles you're trying to prove, you look through your additional tools, and if it makes an isosceles triangle, we conclude that the sides opposite the congruent angles are congruent, or vice versa. Number 2. I'm proving ultimately that triangle ADM is congruent to triangle BEM. So I'm proving that those green triangles are congruent. And again, these are mini proofs. This is not a whole proof. This is just going to be one step within the bigger proof. But we got to learn how to do the mini proofs before we can apply it to the big proofs. CA is congruent to CB, given. CA, CB. Are these sides of the triangles I'm trying to prove? No. They gave it to me for a reason. So I go to my additional tools. VRIAS, vertical angles, has nothing to do with that. Reflexive property has nothing to do with that. I, isosceles triangle. Is there an isosceles triangle here? Yes. If these are congruent, it makes this an isosceles triangle. And an isosceles triangle not only has two congruent sides, but it also has two congruent angles. The angles opposite them. Little technical difficulty there. Oh my god. So again, let me start the thought over. So if the sides are congruent, then the angles opposite them must be congruent. And are the angles opposite them angles of the triangles I'm trying to prove? Yes. So I can say that angle CAM is congruent to angle CBM. And the reason is isosceles triangle theorem. So if they give you sides or angles congruent that aren't in the triangles you're trying to prove, look to see if there's an isosceles triangle. If there is an isosceles triangle and it tells you that these two sides are congruent, then I know that these two angles must be congruent, and those are angles of the triangles I'm trying to prove. And again, going back to the first example that we did, if I gave you that these two angles were congruent, which are not angles of the triangles I'm trying to prove, I can conclude that these two sides are congruent. That's isosceles triangle theorem. Practice it. See ya.